AI models can write essays, generate code, and even solve calculus problems. But sometimes a very simple prompt exposes a surprising weakness. One of the real tasks of an AI trainer is to design prompts that stress test a model and reveal where it breaks. The goal isn't just to get correct answers, it's to find the situations where the model fails. In this case, the prompt was simple. Create a two-dimensional net for a rectangular prism showing all 6 faces connected so the shape can fold into a box. At first glance, that might sound easy. A rectangular prism has 6 rectangular faces, and a valid net is simply an arrangement of those 6 faces that can fold up to form the box. In geometry classes, students often learn that there are several valid nets for a rectangular prism, but each one must meet a very important condition. When the faces fold upward along the edges, they must connect without overlapping and completely enclose the shape. Here is the response the AI produced. The model generated a diagram that looks somewhat like a cross of rectangles connected together. At first glance, it appears reasonable. There are several rectangles attached to each other, and it resembles the type of net you might see in a textbook. But when you analyze it more carefully, a problem appears. If we imagine folding the faces upward, 2 of the panels would collide with each other, instead of forming the sides of the box. In other words, the arrangement of faces does not correspond to a valid folding structure for a rectangular prism. Even though the diagram looks convincing, it cannot actually form a 3-dimensional box. This is the kind of subtle failure that AI trainers are trained to detect. Why does this happen? Language models are extremely good at recognizing patterns in text and images, but spatial reasoning problems, especially ones that require imagining how shapes fold in 3 dimensions, are much harder. Instead of truly simulating the geometry, the model is predicting what a plausible answer might look like based on patterns it has seen before. Sometimes that prediction looks correct, but when you check the geometry, the structure doesn't actually work. This is exactly the type of issue AI trainers are hired to find. The job involves writing prompts that reveal weaknesses like this, reviewing the model's responses, and explaining precisely why the output fails. If you want to practice real AI trainer tasks, like evaluating model responses, identifying reasoning errors, and spotting failures like this one, I've built a training platform with exercises that simulate the kinds of assessments used in real AI trainer roles. You can try the AI Trainer Challenge using the link below.